Welcome back to 3D Decode. Today we'll explore a critical topic in rotating machinery, rotor dynamics as per API 617, along with balancing practices, a quick Pump BEP check, and a datasheet stub you can use in daily design work. This topic often comes up in design reviews and technical interviews, so let's dive right in. Rotor Dynamics Essentials. Rotor dynamics is all about how the shaft behaves under speed and loads. Critical speeds, CS. These are natural frequencies of the rotor. If operating near CS, vibration shoots up. Separation margin SM. Keep the continuous operating speed away from criticals. A margin of at least 10% is typical. Unbalanced response. During run-up, amplitude peaks near CS and phase shifts 90 to 180 degrees. Bode and polar plots help visualize this. Campbell diagram, frequency versus speed. If the synchronous 1/10 line crosses mode lines, resonance is possible. Stability. Watch for subsynchronous vibration like oil whirl and whip. Solutions include optimized bearings, clearances, damping, and oil properties. Balancing in shop and field. Balancing ensures smooth running. Balance types. Single plane for rigid rotors. Two plane for long or flexible rotors. Balance grades. ISO 21-1940 grade G 1.0 is common for high-speed turbo machinery. Formula, permissible residual specific unbalance, E per frac 99549.gn, GM and Kodre, where G equals balance grade, N equals RPM. Total permissible residual unbalance, U equals E per times mg, with M equals rotor mass. Best practice, shop balance the bare rotor, assemble the machine. Trim balance with key phaser after coupling before final test. Always log final 1/10 amplitude and phase. Worked examples. A. Separation margin operating speed. NOP equals 10,000 RPM. First critical. NC1 8,500 RPM. SM equals 10,000 where 10,000 equals 15%. Meets the TOR 10% guideline. B. Balance tolerance. G equals 1.0. N equals 10,000 RPM. M equals 50 kilograms. E per. Frac 95549, Velptot 1, 0.9549, G mm per kilogram. U equals 0.9549 times 50 equals 47.7 diameter. Residual unbalance should be 48 drawer, split across planes. C. Quick Pump BEP Check. Pump BEP 1,000 milligrams. Duty equals 900. 1,000 equals 90% of BEP. Within the 80 to 110% window. Still check NPSHU, NPSHR, and ensure minimum flow protection. Acceptance and test pointers. What to record during tests. Run up Bode plot once amplitude peak and speed. Confirm SM. Steady state. Shaft relative vibration. Millimeter PK. Casing vibration. Millimeters per set RMS. Axial bias. Bearing temps. Trim balance log. Correction plane. Added mass and radius. Final one's amplitude and phase. Mini quiz quick check. 1. Why do we need a separation margin from critical speed? 2. For a 12,000 RPM rotor at G equals 1.0, what is E per in G mil per kilogram? 3. Which plot shows amplitude and phase versus speed during run-up? 4. A pump running at 65% of BEP will likely face what issues? Hat practical tasks. Here are some exercises to sharpen your skills. Rotor dynamics card. Note min, normal, and max speeds. Measured criticals. Calculated SM. Final once amplitude and phase. Axial bias. Acceptance status. Balance worksheet. Compute E per and U for rotor speeds, 8K, 10K, 12K RPM, and masses, 30, 50, 80 kilograms. Pump BEP check. Take a real duty point, compute percent of BEP, and note actions. Throttle, impeller trim, or VFD. Interview Q&A. How do you confirm you're not operating near a critical speed? A. Review Bode polar and Campbell diagrams. Confirm SM bright 10%. Q. What's the difference between shop balance and trim balance? Shop balance is on the bare rotor. Trim balance is on the assembled machine using operating phase reference. Q. What does a stable phase at high 1/10 amplitude suggest? A. Predominant unbalance. How do you distinguish oil whirl whip from unbalance? Oil whirl whip shows subsynchronous peaks, 0.4.5 pipes that grow with speed, unlike unbalance, which shows dominant 1/10 with stable phase. Q. Why keep pumps near BEP? A. It minimizes vibration, ensures best efficiency, and reduces recirculation cavitation risks. Bonus. Pump Datasheet Stub. Fill this in for practice. Includes service fluid, duty conditions, NPSH data, BEP efficiency, casing rating, materials, sealing plan, nozzle sizes, bearings, driver data, and applicable API standards. And that wraps up today's session on rotor dynamics, balancing, and pump BEP checks. If you found this breakdown useful, don't forget to like, share, and subscribe to 3D Decode for more practical engineering content. See you in the next video.